For the following equations, we're going to solve the quadratic equations by factoring and using the zero factor property. So for the first equation here, we have this trinomial, 3x squared plus 14x minus 49 is set equal to 0. Do make sure your equation is set equal to 0 so that it's in proper quadratic form. And as we continue to look at this problem, we try and factor this. Our first step in factoring is to check, do we have a greatest common factor here? So quickly go over your numbers and your variables here. Looking at 3, 14, and 49, those three numbers do not have anything in common. We also do not have an x term, an x value in all three of these terms, so we don't have anything in common there, which means that we can move straight to our factoring technique. Now, because this is a trinomial with the leading coefficient that is not 1, we are going to use no-fuss factoring in order to solve this. So there's 4 steps to no-fuss factoring. Okay? So we set up our set of parentheses that we have to factor into, and the first step of no-fuss factoring says to take whatever this first term is here and repeat that twice in these first positions. So this would be 3x and 3x. Step 2 is to take the first number and the last number and multiply those together. 3 times 49. And when we do 3 times 49, we get 147. Which brings us to our next step here is what we need to do is we need to find 2 factors that multiply to get 147, but add or subtract to get our middle term here. Right, so they need to multiply to get 147, add or subtract to get 14. So that means we need to go through and figure out, well, what multiplies to get 147? And you can play around with the calculator if you need to in order to find the proper values for it. But 7 times 21 is equal to 147, and 21 minus 7 is equal to 14. So those are going to be our magic numbers that we're going to plug in here. The next thing is to figure out what signs you need to have for these problems, and you always focus on the last term for your signs. Remember that these 2 numbers need to multiply to get this back term over here. So we need to think, how do we multiply in order to get a negative for this last term? Now, when we multiply, the only way to multiply and get a negative is if they have different signs. One has to be positive, one has to be negative. To figure out which one goes where, we look at our middle term. And we need to remember, whatever sign our middle term has, the bigger number out of these 2 needs to have it. Since our middle term is positive, that means the plus will go with 21. And since they have to be different signs, that means we need to have a minus with the 7. The last step in no-fuss factoring tells us that we need to reduce one or both of these factors. So think about like simplifying fractions and taking a look at our first factor, does 3 and 7 have anything in common? Well, they don't. So that means that one's simplified. We can drop that one down. Looking at our other one, we're then going to look, well, does 3 and 21 have something in common? And they do, because you can divide out a 3 from each one of those. 3 divided by 3, 21 divided by 3. So we're going to go ahead and do that and reduce this factor. 3 divided by 3 cancels out to a 1, so we drop down the x, plus 21 divided by 3 is 7. This is our factored problem. The only thing left to do to wrap up this problem is to use the zero factor property, which tells us if this times this equals 0, that means that one of these factors needs to equal 0. So what we do is we take our 2 factors and we split them up and we set them each equal to 0, and we solve these equations. Solving the first equation here, we add 7 on both sides. And then we divide by our coefficient of a 3 to get that x is equal to 7/3. Solving the other equation, all we have to do is subtract 7 on both sides to get us that x is equal to -7. So those are our 2 solutions for this problem. We got that x is equal to -7 and 7/3. Let's move on to the next one. For our next example, we have 24x squared plus 6 is equal to 24x. So for this one, the first thing that we should hopefully be noticing is that this equation is not set equal to 0. It must be set equal to 0 for it to be in proper quadratic form. So the first thing we're going to do is we're going to take this 24x and we're going to subtract it over to the other side so that it's in proper quadratic form first. Once it's in proper quadratic form, then we can focus on the factoring portion of it. So this is a trinomial with a leading coefficient that is not 1, so we're going to use no plus factoring once again for this one. But before we jump into that, I see that I have a 24, and a 6 here for my numbers. They're all even numbers, so I do know that they have something in common. They at least have a 2 in common. But if we look at 24, and 6, they have a common factor of a 6. That means that I can factor out 6, which is the same thing as dividing it out, so I can figure out what my simplified trinomial is going to look like. Dividing this out, 24 over 6, that gives us 4x squared, minus 24 over 6 is a 4x, plus 6 over 6 is equal to a 1. Now we can work on factoring this problem here. So step 1, repeat the first term twice, 4x, 4x. Step 2, multiply the first number times the last number. That gives us 4 times 1, which is just a 4. So we want what multiplies to get 4 and what adds and subtracts to get our middle term, which is also 4. Well, the only way you get 4 is 1 times 4 and 2 times 2. We do want the 2 and the 2, since we do want them to add or subtract to get a 4 here. Focusing on our signs, our last term is positive. Remember, the only way to multiply and get a positive number is if they have the same sign, either plus plus or minus minus. To figure which one it's going to be, we take a look at our middle term. Whatever sign the middle term is, the bigger number has to have it. These are both the same number, so there's not one that's bigger than the other one, but the negative tells us that that must be the negative combination instead of the positive combination, since this middle term here is negative. The last step of no fuss factoring tells us to reduce one or both of our factors. Taking a look at our first one here, we have a 4 and a 2. Looking at 4 and 2, we know that we can reduce those by a factor of 2. And when we do that, 4 over 2 gives us 2x, minus 2 over 2 is 1. Same thing for this one back here. Do notice these are the same factors, 4x minus 2, 4x minus 2. So we could also factor out a 2 from this one to get us 2x minus 1. Now we can drop this 6 down, but if we're taking a look at this problem here, we're done with the factoring. All we have to do is solve by using the zero factor property. When we solve using the zero factor property, we take all factors that have a variable in it and set them equal to 0. This 6 is insignificant. You don't take the 6 and set it equal to 0. That would make no sense. So anything that has an x in it, you're then going to separate it, set it equal to 0, and solve. They are the same factors, so there's no point in solving both of them. We would get the same exact thing. So if we solve one of them here by adding 1 to both sides, and then dividing out the coefficient here, we see that we get x is equal to 1/2 of our solution. And we are going to get 1/2 for both of these. There's no need to state 1/2 twice. We just say that x is equal to 1/2. For example C, we have n plus 5 times n minus 7 is equal to 28. Now if this problem were set equal to 0, it would already be in factored form and we could go straight to the zero factor properties, split these up and solve. But because it's equal to 28, we can't do that quite yet. Remember, a quadratic equation, you want everything over to one side of the problem in order to solve it first. So what we're going to have to do is we're going to need to do a little bit of algebra to clean this up. First thing I'm going to do here is actually multiply these two factors out. So I'm going to use the FOIL method here to multiply. Remember that F stands for first, n times n gives us n squared. O stands for outside, so that is your -7 times the n, which gives us -7n. I is inside, 5 times n gives us 5n. And last, 5 times -7 is -35. What I'm also going to do here is I'm going to go ahead and subtract this 28 over to the other side. So I'm going to tack that on right over here so that our equation is set equal to 0. So I have everything over to one side of the equation. Now we just need to do a little bit of cleanup, combine some like terms. We have two sets of like terms here because we have the negative 7n and the 5n. And then we have the minus 35 and the minus 28. So dropping down the n squared, negative 7 plus 5n gives us a negative 2n. And then negative 35 minus a 28, so let's see, that gives us a negative 63 there, all set equal to 0. So now it's in proper form, it's simplified. That means we can now move into our factoring here. So this is factoring a trinomial with a coefficient of a1, so we can jump straight into the factoring here. Looking at our first term, n squared, the only way to get n squared is n times n. Then we look at our last term, which is a 63. So we're looking for what multiplies to get 63, but what adds or subtract to get our middle number, a 2. So there's a lot of things that multiply to get to 63. Let me see here. So 63 is 9 times 7. Excuse me. And 9 times 7 is 63. 9 minus 7 is 2, so those numbers do work for us. I'll put the 9 in here, the 7 in there. Looking at my signs, the 63 is negative, so that means they're going to have different signs. Because our middle term is negative, that negative needs to go with our bigger number, the 9, which means the plus must go with the 7. Last step here, use the zero factor property to take each factor, split them up, set them each equal to 0, and solve. Now the solving is just a one-step problem here. For this first one, we're going to add 9 to both sides to get n is equal to 9, and then subtract 7 on both sides to get n is equal to negative 7. So here we get that x is equal to a negative 7 and 9. For example D, taking a look at this problem, we need to factor this and we need to solve this. In order to factor it, we need everything over to one side of the equation to where it's set equal to 0 in proper quadratic form. So in order to make that happen, I'm going to take this 3m and this minus 5 and I'm going to move it over to the other side of our equation. Since this 3m is positive, I'm going to subtract it to both sides. And actually in the same step, I'm going to go ahead and say plus 5 to both sides. That way they cancel from the right-hand side and it's set equal to 0. On the left, I'm just going to drop down the 10m times m plus 3. And then we subtracted 3m and then we added the 5. We just moved those two terms to the left-hand side. Now we still need to do a little bit of cleanup here because I see this 10m is getting multiplied to the m plus 3, so we need to distribute that. 10m times m gives us 10m squared. 10m times 3, the 10 times 3 gives us 30, and attach that m to it. And then drop down the rest of the problem of a minus 3m plus a 5 is set equal to 0. A little bit of cleanup here. Let's combine those two middle terms to give us 10m squared plus 27m plus 5 is equal to 0. Now we're ready to jump into the factoring for this problem. Just real quickly check to see if there's a greatest common factor, but if we're looking at 10, 27, and 5, those numbers don't have anything in common. So I'm going to draw my parentheses, set them equal to 0, and since this is a trinomial with a leading coefficient that is not a 1, we're going to use no fuss factoring again to factor this, which means this 10m, repeat that twice, 10m, 10m. Take the first number times the last. That gives us 10 times 5 is equal to 50. We're looking for what multiplies to get to 50, but what adds or subtracts to get 27. So let's see, let's go ahead and make a list here. 1 times 50, 2 times 25, and actually that's as far as we need to go since 2 times 25 is 50, 2 plus 25 is 27. So popping in the 2 and the 25 there, Everything is positive in our trinomial, so that means everything is positive in our factors. Last step of the factoring process says to reduce, simplify your factors. One or both of them. At least one of them will be able to be reduced. Sometimes both, sometimes just one. Taking a look at the first one, 10 and 2 has a 2 in common, so we're going to divide a 2 out from that. When we do that, 10 over 2 gives us 5m, plus 2 over 2 is 1. Our second factor, we have 10 and 25. Those also have a factor in common of a 5. So we're going to divide 5 out from both of those. 10 over 5 gives us 2m, plus 25 over 5 is 5. Okay, so these are our two factors. At this point, we're using the zero factor property to split each one of these up, set them each equal to 0, and solving. So real quickly here, I'm running out of room. I'm going to go ahead and write this up here. To solve this one, we have this plus 1, so subtract it on both sides, giving us 5m is equal to negative 1. And dividing out the coefficient, we get that m is equal to a negative 1/5. For our second equation over here, we had 2m plus 5 is equal to 0. Subtracting the 5 on both sides give us that 2m is equal to negative 5. And then dividing out your coefficient gives you that m is equal to a negative 5/2. So our two solutions here, m is equal to a negative 5/2 and m is equal to a negative 1/5.